Okay, yesterday, when was it? No, the day before yesterday, I went for a swim and there was someone in front of me on a board and I was body surfing, and if I'd kept on the wave, I would have just crashed into him. So I pulled out of the wave and I twinged this muscle in my neck. Now, by coincidence, my wife had been to an acupuncturist who had that day taught her where the pressure point for the neck was, and my wife had a couple of needles and she said, I know exactly where it is and I promise you it won't hurt. And she put the needle into a place in my hand, and the good news, it did relax my neck. The bad news is I went, ow! And it really, really hurt. And my daughter said, what was that? And I said, oh, it just hit a nerve. And she said, what's a nerve? And I realised I didn't know, which is why we're talking to Professor Matthew Kiernan, who's from the Neuroscience Research Australia. Hello, Matthew. Hang on, sorry. Hello, Matthew.
Hi, how are you going?
Good, good. Now, you're on Twitter, aren't you?
I am on Twitter.
So do you, quickly as a neuroscientist, before we find out what nerves are, have a quick view on whether tweeting actually makes you think better and more?
It absolutely does.
Good.
And it's a critical media. You got to get into it, James.
If it makes me think more and better, then I'm the case is being made.
There's also now the Journal of Nano, and that's just a pure journal based on tweets. So you can really learn quite a lot in a few minutes.
Really?
Yeah.
Okay. Now, we're talking to another neuroscientist in about 15 minutes, Mark Lewis, who's written a book called Memoirs of an Addicted Brain about his time as a user of drugs, and explains it brilliantly. So I hope you can listen to that if you're interested. But tell me what a nerve is. When my daughter said, when I said it hit a nerve, and my daughter said, what's a nerve? And what should I have said rather than I don't know, actually?
Well, I mean, a nerve is part of the whole nervous system. And people often wonder, what's the most important organ in the body? But you can sort of joke around about it, but really the most important organ is clearly your brain.
Yeah.
And that controls everything we do. You talked about swimming, surfing, pulling out of waves. All of that is signals coming from your brain down through your spinal cord into your arms and legs, activating muscles. But it also does much more than that. It does all these things that we're almost subconscious to or unconscious to, like breathing, controls your heart rate, it controls your stomach and eating, and then in your case, skin. So there are little nerve roots in skin, and when you touch one of those nerve roots, it sends a signal very quickly, and it's sort of equated like a kangaroo jumping along from, the periphery up through to the brain to make you register that something bad is happening here and to pull your hand out of the way. Now, I'm sure the acupuncturist was very good, but, it's giving you a signal to move.
Yeah, right. And are they everywhere? I mean, with a pin, and I don't suggest people do this, but if you got a pin and started poking around on your skin, would you hit a nerve every time or only now and again or mostly?
Well, every part of the skin is innervated or supplied by nerves. So, yeah, you'll feel it every time, unless there's been damage to a nerve.
And then, so why did this needle go into my skin? And it was all fine. Maybe it went a little bit deeper than they normally do. And then, bang, almost like an electric shock.
That's exactly it. But I have to say also, some of us have different pain levels, James.
Mine's very low.
Yeah. That's the impression we're getting.
Yes.
But maybe it went through, the outer levels of skin are sort of not innervated, they're sort of dead.
Right.
So then once you get into real skin and the underlying sort of dermis, that's all got nerve supplies. That's when it's triggered off.
Okay, now when you say nerve supplies, I know what my skin looks like, but what do the nerves supplying them look like?
It looks like a spaghetti junction underneath. Like if you got a microscope and looked at it, it's thousands of little lines and tubes of nerves, and they all come into a much bigger, it's like an electrical cable structure.
Yeah.
So it's got insulation, which is called the myelin sheath, and in the middle is the axon or the nerve itself, where the signals are passing, and it's all electrical. So we are an electrical being. So if I put an electrode on my brain, I can record continuous activity. If I put electrodes over, skin and so on, we can record these activities. So we are purely electrical structures, but we've evolved. Obviously, we're thinking about it. And also, when we start to move, there are things going on, like we're planning all of our movements.
Yes.
And planning what we're going to say, what we're thinking.
And so it's almost like the skin, that's a layer we can see to keep everything else in, like a big bag. The bones are to help us stand up and move. The muscles too, but the veins to pump blood. But there's another layer that covers all of us, which is the nerves.
Absolutely.
And what are they? So you've described what they look like, I guess. What are they made of?
They're made of proteins, and in fact, one of the most important parts of the protein is they're called channels, the sodium channels. So these channels are opening and closing very quickly, and sodium's passing in and out, and that's how the signal is passing along. The other side is the insulation, which is myelin, and that again is a protein structure. So it's all a very sort of hardwired protein network.
Right. And when people have nerve damage, now a nerve it's not just receiving pain, it is basically our sense of touch, isn't it?
Absolutely. And it's also a sense of nutrition. So nerves are also an energy supply, and they're passing chemicals down, but also nutritional components. So there's what's called axoplasmic transport. So structures can be passed up and down nerves in a good sense, but also in a bad sense. So if you get toxic exposure, it might travel up through peripheral nerves and into the brain and cause a reaction or an infection.
And if you have nerve damage, just your nerves, say, in the bottom half of your left arm cease to work, and maybe you can tell us how that can happen, or whether it can happen. But it's kind of, is it less? Does that mean you can't move your arm, or you can't feel your arm, but you can still move it, or what?
So the nerves are divided into two main groups. So there's sensory nerves and motor nerves. And the sensory nerves are more for feeling, and the motor nerves are for moving.
Right.
And let's say, for instance, you pulled out of the wave and a surfboard fin cut across your arm and cut the nerve.
Yeah.
So you would have no feeling, or if it was a motor nerve, you wouldn't be able to move the arm below that lesion. And gradually...
So are there sort of artery nerves, like there's arteries for blood, main highways?
Absolutely.
Yeah, I get you.
Yep. And if, the question is it a complete transection or a complete cut? If it's only a partial sort of stretch or a little tear, well, the nerve will repair itself.
Yeah.
And nerves grow back 1 millimetre a day or an inch a month. So if it was like a big area of the nerve affected, then it might take a few months for it to sort of grow back. There's always been this view that nerves are, once you're born with your nervous system, that's all, that you can't change it later on. But there is, as you mentioned, this idea of plasticity. And this is really one of the boom areas of neurosciences at the moment, how can you try and make nerves recover for simple things like cutting them, but also in neurological diseases like multiple sclerosis, motor neurone disease, Parkinson's disease, trying to grow things back, or even after a stroke when a part of the brain is affected, other parts of the brain can basically morph to take over new functions or to serve functions that they weren't meant to do originally. And we have a lot of pathways in the brain that were there when we were basically before we were born and in the first year or two after we're born, and they get gradually subserved by other parts of the brain as we start to mature and start to develop. And particularly our frontal lobes take over those sort of functions, and they control how we interact with each other. So how we're talking now on the telephone, and how we, when we meet someone, we shake hands. And there's a very ordered way of going through life, and that is controlled by our frontal lobes, which is really executive behavior. But if you damage any of those areas, for instance with a stroke, other parts of the brain can gradually take over, providing there's enough left to do that.
Wow. Thank you very much, Matthew.
Pleasure.
That was, I know a lot more, and I'll be able to answer questions from my kids more knowledgeably, which is important.
Well, hopefully I wasn't explaining sex to a virgin.
Good to talk to you. Professor Matthew Kiernan from the Neuroscience Research Australia.